Okay, hi AlgoFan, welcome to the session 2 of our Intermediate Python Bootcamp. Thanks for joining us and starting this journey. A quick recap of yesterday's session. We improved our smart contract and add boxes. On the chat, you can share with us your thoughts on yesterday's session and let us know if you were able to recreate the improved contract for the digital marketplace. And today, as we did on the beginner bootcamp, we are going to create the test to ensure that everything is working as we expect. And we are almost to start today's session. Who is ready for the content that Giorgio, Joe, and all the development team had prepared for us? And a quick reminder, the sessions are recorded, and when the session is over, you will receive the recording in your email. In session 4, I will share the link so you can claim the certificate of completion. And yeah, those are the most important things. I don't know, Joe or George, if I'm missing something that we need to share with the community today before we start.
No, I think we're good to start. I already see some questions in the chat that we can get to.
Yeah. In fact, let me answer Harry's question before we get started. So he noticed some differences between the link that we provided and the contracts that we are writing right now. And yes, he correctly points out that there are some internet runs in the contract that we provided in GitHub and not in the contract that we're writing. There's no statement about the fee being equal to 0, and there may be differences between the asset ID and just the asset, and that depends. If you look at the signature of the method, some methods may accept a number as an asset ID instead of an asset. So the quick explanation for that is that you can, if you don't need to access any properties of the asset during a contract execution time, you are fine to only pass a number to a method. However, if you do need to access asset properties, like the number of decimals, the metadata about it, or accounts balances for that asset, then you do need to import, to accept an asset into your method. So this may be the difference that we notice between the two contracts. They both work, and the only difference, if you see asset.id instead of asset, the only difference will be in the contract's method definition. So hoping that this clears it up.
Yeah, and also on the fee equals 0 side of things, in the 2.0 version of the compiler, the default behavior has changed. So now if you don't explicitly specify a fee, it defaults to fee equals 0. So in the past, you had to explicitly write fee equals 0. Now you don't necessarily need to write it. And if you can still have your contract pay your fees if you set fee equal to the minimum transaction fee, but the default behavior now is just to hard code the fee to 0, even if we don't manually specify it. And that's more or less a kind of a safety feature for the reasons we talked about yesterday about how otherwise fees might come from the contract account. So the compiler will now automatically set fee equals 0 for you. So you don't have to do that yourself.
Awesome. Thanks for the explanation, guys. It's also important to remember that we have the question tab, so you can put all the questions over there. So for us, it's easier to answer. And also when you are watching the recording, you will have everything in just one place, because sometimes when you put in the chat, it's a little harder to see all the questions. And remember, we are working, as my teacher is Python for blockchain, so we have a lot of things to keep building around this. We are ready for session 2, guys. And yeah, We are learning together. Thank you for joining us.
All right, so I'll go ahead and get started playing our videos. Like always, like Camilo said, got a question, definitely prefer you use the questions tab. Makes it a little bit easier to see for everyone. If there's a big question, we can pause the video and address it on the video. Otherwise, we'll just respond in the questions tab. So like Camilo said, we'll be doing testing today. So we'll go ahead and get started with that.
Welcome back, everyone. And in this session, we're going to write the tests for the contract that we wrote yesterday. This will be unit tests as AlgoKit provides us with the framework to do. And these tests are going to be really important for us to... Welcome back, everyone. And in this session, we're going to write the tests for the contract that we wrote yesterday. This will be unit tests as AlgoKit provides us with the framework to do. And these tests are going to be really important for us to understand if our contract is doing what we actually want it to do or not. A couple of things that we have to sort out before we start writing code is that you need your Docker running and your local net. In my case, I have already started those. And if you are unsure, you can check with AlgoKit local net status. And if that is up, it will tell you a bunch of information about your local net. And actually, I think I'm gonna reset it while we talk about some other things. So for our testing, much as we did in the previous session, in the previous bootcamp, sorry, we're going to use some beta features of AlgoKit, and that's the Algorand client. And that features are on a beta version of the packages. So in order for you to be on that version, you need to type in this command. I will paste this link in the chat while we are coding together. Just bear in mind that at some point all these versions are going to be released, and you will not need to do this step if you're watching this in the distant future. But yeah, so I'm gonna hit enter, but I have already done this step, so I don't need to do it again. So in our, let's open the test file, tests, and we are in the contracts project. We want to open the digital marketplace test. Now from this, let me check my script. Okay, yeah, we will be importing a bunch of things from this beta version of the packages. For now, we actually want to write some fixtures. There are some accounts and some objects that we would like to reuse throughout all tests, and so we need to write this cached object before writing any actual test. I'm gonna make a copy of the constant that we need. No, that's not the file. Of this constant that we need here. Okay, I'm gonna keep a terminal open just because I want to be able to run linpix every once in a while. Okay. So we want to have a dispenser. This is an account, a particular account that we will use to fund other accounts, and we're going to have like the creator account and the buyer account. So this is a fixture. with the scope equal to session. Oops. Now is the place where we want to start importing the algorithm client. Is that suggesting that we already have an algorithm client? Hold on. What do we have in the conf tests? No, we didn't write an algorithm client yet. Should we? Let me check my script. Ah, yeah, we should. So why is this then suggesting? Oh, it's not suggesting it anymore. It must have been a bug of the IDE or something. So my bad. We actually want to go into the conf test file first because we want to have a kind of a module defined fixture. This is called the algorithm client. And this is returning, yeah, this is returning an algorithm client. Sorry for the interruption. Okay, so this is returning an algorithm client. And this is client. Let's make a temporary object. Wait, should we import this from somewhere? Yeah. Let me check. We'll import that from, yeah, from here. Logit utils.beta.algorithm client and import algorithm client. Okay. So we make a temporary object and default local net. A client set suggested params timeout. Okay, so what this means is that the client will be pointing to local net, which is what we want for testing. And this is saying that for each transaction that we will construct or build or send with the algorithm client, the timeout for caching the suggested params should be 0. We want this for local net because actually local net works in such a way that it never advances by a block unless there is a transaction to be there's a pending transaction. So if you cache these suggested params in local net, what will happen is that each new block you will get the old parameters and it will give you an error pretty quickly. So you don't need this for other networks, but you need it for local net just because each transaction changes instantaneously almost the block, and so you want to have the suggested parameters being updated regularly. So once we make this modification to the client, we return it. And that's all that we need to do in the conf test file. What's the problem here? Oh, right, we left some code here, not completed. Okay, now we're defining an account. Yes, I want you to import that. And this is returning an address and signer, which is also something that we want to import. You can see all the imports here, like from beta, account manager, address and signer, beta, algorithm client, algorithm client. This is returning an algorithm client, count, Spencer. Okay. We also need a creator we almost imported an algorand client. No, we want an algorand client. And we want to also import the dispenser as an address and signer. And this will also return an address and signer. So for this, we want to have just a random account. So because the difference would be that each time you reset your local net, you get a set of addresses that start with initial funds. However, if with every test we were to use the same accounts, we would essentially see every time the results or the side effects of the previous tests run. That we don't want that. We would like to keep, as much as it's practical, these accounts separate. So that's why this is a random account and this is not, because this dispenser account always owns funds initially and this random account doesn't. So we use the dispenser account to fund this new created account. That's what we're going to do. I'm going to client, send the payment to, we need the pay params, which is another object that is imported from beta.composer. Sender will be dispenser address. The receiver will be the newly generated account. And for amount, let's say 10 algos. So 10 million micro algos. Okay, let's return the account now that we have funded it. Okay, now that we have the creator account, we want to create assets that will last for the whole session of the test. So we create another fixture. We need a creator and an algorithm client. This will return a pair of asset IDs. And we are creating two test assets because, of course, one of the things that we would like to check is that we can actually put more than one listing into the same contract. And ideally, like everything, we would like to check many code paths. So we don't want to just check that the same creator with the same asset can create more listing for a different nonce, but we also want to check for different IDs too. So we can also check more code paths. Let's return a pair. Client, send an asset create. We will need the asset create params. Now, this is what we talked about yesterday, right? It looks like I'm creating 10,000 units. I'm not. I'm just creating 10 units, but each of these units is going to have 3 decimals. So that's why the total needs to include all all the 10 with plus the decimals. And out of this transaction, we want to just remember the ID of the created asset, so confirmation, and asset index. Okay, we can essentially copy this, put a comma here. So we are creating two different assets, but with kind of the same properties, but they will show up with two different IDs and be two totally different assets. Okay, we now need the other account that we talked about, which is the buyer. This is the buyer. We'll need an algorithm client. We will need dispenser, which is an address and signer, and we will need the test IDs. I'm sorry, the test asset IDs. And this is a, you mentioned it is a pair of integers. Let me check if this will return the buyer address. And just for now, let's run the tool so it can format our code for us. Okay. Now, what we want to do actually is not only create a new account and fund it, but we want the buyer to also opt in the assets that we just created, because we, like, in order for the buyer to buy them, they need to be able to accept them. So what we need to do for this is essentially some of what we did before. Algorithm client, account random, create a new brand new account, fund it, send the payment, pay params, send is equal to dispenser, the receiver is the newly created account, and as an amount, let's do 100 outgoes. Just because this account also needs to pay for the assets on top of all the minimum balance requirements that we have. Now we want to opt in, we want to have this account opt in to the assets. So for each asset in the test assets ID, we should do an algorithm send opt, asset opt-in, there you go. And we need asset opt-in. Import that object. The sender, sorry for the pop-up. The sender is going to be the account. The asset ID is the asset in the loop. What's the problem? Test asset ID. Oh, that's bizarre. This should be recognized as an integer, right? Because this is a tuple of integers. So, well, let's review that later. And then we need, I don't think we need much else. Turn the account. All right, okay. Asset ID is equal to the asset. Perfect. Okay, do we need to do anything else? I don't think so. Perhaps we want to change the deploy. I think so. I think so. Yeah, this is. Let me just go on a little bit of a tangent about deploy. Deploy is a very useful feature of a client generated with AlgoKit because it allows you to both from your CLI and from CI/CD pipelines deploy new contract code. And it will do so such that if there are no actual changes, like if your code changes but your contracts do not change, it will correctly detect that and it will not perform updates of sorts. So it's a very useful feature. I find that during tests, this ends up doing more harm than good, because maybe you're writing tests not like we are doing now with the contract finished. We have the luxury to do that only because I already have this project built and I'm just copying stuff over and we're doing things together, but I already know that works. But sometimes it can happen that you are writing the test while also writing the contract. So you end up making lots of changes in both places at the same time, and it becomes difficult to track if you're using an old version that is still equivalent to the last one. What if the change that you made in your contract is not being correctly detected, because who knows? So all of this is to say that I don't usually use deploy in my tests, and I deploy the app manually every time because this has the potential to not actually change the app on the chain. So I would say let's comment this bit of code and say client create. This will create our contract, and we need to make sure that this is funded. So allocate utils, ensure funded. For some reason this is not requested by this. Oh, I see. Oh, we need to import this. Yeah. I think we can get rid of both of those because we can just import the algorithm client. And that, we need the creator, of course, but address and signer. But by having the algorithm client here, algorithm client can become algorithm client algorithm. So, and for indexer this is indexer. Perfect. Okay. Do we need to actually... yeah, I need to change also like how we create the client. So this will be the creator, address, and the signer will be... Let's get rid of this line. So what are we missing here? So we need the algot client and then, the parameters. We need to tell it how much we want it to fund it with. So algokit utils.ensure balance parameters. And this will take an account to fund, which is going to be the application address, and a min spending balance of 0. Now, it may look strange that we are asking it to ensure that something is funded, and we say that the minimum spending balance is of microalgos is 0. But this is actually what we want, because this function will correctly understand that each account at the very minimum needs 0.1 algos, and everything that you specify here is on top of that. So this is actually the correct way to ensure that something is ready to accept algos and ready to have an online address. Okay, I think for now we are finished with the slide. We are finished with the fixtures, so I think this is a good place to stop the recording and start the next one. Okay, so in this recording we set up all the fixtures that we need for the actual test that we're going to write in the next recording. And let me play the next recording then. And with any question, or feel free to use the questions tab. In this recording, we are going to start writing tests. So we can get rid of the previous tests that belong to the template. And the first test will be, actually, we'll be testing the first deposit method. Yeah, this deposit here. Hold on. Oh, no, that's not true. We're going to test the allow assets. Yeah, that makes more sense, because we want to test that we can have the contract opt in to assets first, and then we want to perform deposits. Okay, we don't need this file. So the test is test allow asset. We'll need an Algorand client. A digital marketplace client. The creator. Oh. And the test assets. This test is returning nothing. So, okay, we want to do this for both assets. So for asset in test asset ID, we call that this asset ID. No. Okay, let me check my notes for a second. We want okay. So we are checking that this contract does not own the asset that we are trying to make it opt into. Because if we take a look at the contract, we will remember that we said this method can only be called if the contract is not already opted in to the asset. So that's what we're checking right now. So, and the way that we do this is that we use PyTest raises, which says that we can give it a function HTTP error. We can give it an error that we expect the function to raise, and if that function raises an error, then everything happened as expected. The function that we will give this test, this functools partial, and this is essentially the functool partial tool is something that creates kind of a lambda function, like kind of an anonymous function. So this is returning a function object and not the result of a function. We need to import functools. The algorithm client algo d, and account asset info. So we want to check that. We don't want to call this function again. We want to specify which function to call and the arguments, and the partial will return kind of a lambda function of that. And the first argument is going to be the address of the application, and the second the asset ID that we want to check. And so again, when we create this function, we are saying that algo D should check what is the balance of the application address for that asset. We expect the contract to not have that asset, so this should generate an error. And if that comes up as this error, then this is successful for us. We want to call the method on the contract, allow asset, with we have to pay for the minimum balance requirement increase. So that's a transaction with signer. Or maybe I think perhaps should be able to, oh no, let's do it this way. So transaction with signer, we need to import this. That's bizarre. We should, this should prompt us to import it. I think let's import it by hand. This is an object within, I don't need this anymore. This is an object in, let's say, from Algo SDK, atomic transaction composer, import transaction with signer. And oh, I see, I misspelled transaction with signer. And so we are trying to pay the MBR increase for the contract, opting into the asset. So this is this transaction with signer takes two arguments. One is the transaction and one is the signer. And so the transaction is an algorithm client, transaction payment with paid params, where the sender is the creator, receiver is the application address, amount, we took a note of this amount, is the for sale box MBR. Wait. Should this be the for sale box MBR? I don't think so. Oh, I have it. I was looking at the wrong segment of my code. Yeah. Yeah, exactly. This shouldn't be the for sale box MBR. This should be the amount that the contract needs in order to opt into the asset, which is 0.1 algos, or otherwise it's 100,000 algos, micro algos, sorry. And the extra, we want to also send an extra fee because the contract is going to issue an inner transaction used to opt into the asset. Okay. So I think we also want to say who the signer is for this transaction. So I think the signer is the creator dot sign. And then we also have other arguments for the contract method. One is the MBR pay, the asset. So the asset is just asset. So the asset is just asset. What else? And then we have the transaction parameters. I don't think that we need to set this to anything other than the default, so this should be fine. Okay. And we want to assert that this method at the very least executed successfully. So we're going to do that by asserting the confirmed round. Okay, so the difference will be that we are going to run the same function after this method, and we expect this to not raise anything anymore, but to give us the correct balance, which should be 0 because we just opted into the asset. So we can call the algo client algo d, and then call count asset info. Again, the address should be the digital marketplace address and the asset. And this right now should return a bunch of information. Asset holding. And the amount, the amount should be equal to 0. Okay. I think let's build the contracts, because I cannot remember if we did it the previous time. So project run build, and now I think let's try and test this. Okay, perfect. So one test passed. That's perfect because it means that every fixture that we have is correct, and it means that we have a creator that is correctly funded, and so yeah, this is a pretty good result. It also means that this correctly raised an error and this didn't. Okay, I think let's go forward with the next test. Okay, now we're actually going to test the first deposit that a user makes into the application. So test first deposit. Now go to client, a digital marketplace client. And actually this is the same setup as before. Asset in test test. Oh, making the same mistake 3 times in a row. Okay, so what we want to test right now is if we can make a deposit. So let me just check my notes and see where to start. Right, okay. So the result should be of the method first deposit, right? And it should be with the MBR pay. Yeah, the MBR pay this time is paying for the box. We made the difference between a first deposit and just a deposit, because in the first deposit you also need to accept money to create the box. So that's the difference between first deposit and deposit. This is again a transaction signer. Transaction is a payment. From the creator. Sorry about this pop-up. Okay. Receiver is the application. Amount is the for sale box MBR. And we want to group with this an extra fee. Wait, hold on. Why? This method does not issue any inner transaction, so I'm confused as to why we need the extra fee. Oh, must have been an error from my code. So let's assume that we don't, and if we do, we'll review later. Oh, that's my bad. So we need to also attach a signer to this. And then we have other arguments. We have the actual transfer, the actual deposit. So this is an asset transfer. With an asset transfer params. Let's import the object. The sender is the creator. Now I'm just going to point out that the creator is the creator of the application and the asset. So this at the moment holds the total reserve for that asset. Hold on, let's first specify the asset ID. This is the asset. Then the receiver is the application. And the amount, let's sell 3 units. Perfect. Now, another argument is the nonce. And just in case that, I haven't made myself clear enough with the nonce, imagine that you're trying the same creator, I'm sorry, the same user is trying to sell the same asset twice. There could be reasons for that. There could be, maybe I want to sell a portion of my assets at the lowest price in order to sell them quickly, but I don't want to sell everything that I have, and I want to put the orders right now. I don't want to be online to check the status of the order, right? So the nonce would be a differentiating factor between these two orders that allows us to uniquely identify them. Since this is the first, I think we can go for a counter, and so just start at 0 and keep it simple. We want to sell this for, let's say, 1 hour ago right now, but we're going to change it later to make the numbers interesting. Okay. Oh, okay. Now we touch on a point. So this contract is going to need to access the related box, the box that has this key, right? The sender, the asset ID, and the nonce. So we need to tell this application call to include a reference to that box in the call. So let's do that. Say that one of the additional parameters is boxes. And this is an array because in principle we could specify more than one box. We haven't calculated the box key though. So that's what we need to do before computing this result. The meaning of this, each box, hold on, let me check the documentation so that I can say the correct information. Yeah, so this 0, it is, in principle, this is an application ID. Now, in the case where all the boxes that you need to include belong to the application that you're calling, this can just be 0. We can take a look at the documentation. This is a box array. That's why it is in an array in Python. And the second input is the name of the box. So that's why we are specifying the box key. Now, these boxes, it can get complicated, especially if you're making inner application calls to other applications. It can get, complicated for resource sharing, which is something where resources that are available to some transaction in the group are actually available to all the transactions in the group. These are kind of complicated use cases. For now, just know that these concepts exist, but if you're using like a single application, you can just put a 0 and then the name of the box. So what is the name of the box then? Well, we said that it is the address of the sender. So in this case, it's the one that is depositing. And we do that. We need to use the algo SDK because we need to get the encoding. Hold on, let me first write it down and then we'll talk about it. So somewhere in our docs, it will say that each time you are interacting with a contract, maybe we can look for this information live. API encoding. Hold on, let me look for this information and then we'll talk about it. Okay, here we go. I found it. So this chapter in this page, technical FAQ, talks about the encoding and decoding of the address. And so this is the form that we are familiar with. Now, that is just like a human readable encoding of the actual bytes, underlying bytes. And what this note is saying to us is that smart contracts operate only on the 32-byte version. So any interaction where an address is used should be translated prior to passing it to the smart contract. This is handled automatically in some cases. Okay, so essentially what we're saying is that this is not one of the cases where this is handled automatically, right? Because we're not just passing an address as a sender, as a receiver. We are kind of using the underlying bytes to construct a box key. So when in the contract we say transaction.sender.bytes, this automatically means that the key is made with the bytes of an address, not with the human readable version of the address. So I hope that clears it up, why we have to do this encoding step while constructing the key for the box. With that said, we're missing the asset ID, and again, similar thing happens for the asset, for the ID of the asset. And then we have a nonce of 0. But essentially what this will do is this will take care of taking this number and converting it to the bytes of a number in the same way that the AVM would do it. Okay, so I think at this point this should pass, and so let's just confirm that it does. And perhaps this is enough for us to already run. And we're missing some piece. We want to make sure that we actually made that the result of the content of the box is the same that we expect, and we'll do that. But yeah, so this is at least it is at least executing and issuing a transaction that does not result in an error. Now, I mentioned that we want to check that the content of the box is what we expect it to be. Application box by name. Application box by name. So the ID, we want the ID of the application, and we want the box key. And we are only interested in the value of that box. This will be the content. We're going to have to decode this content because just because it is sent through the wire, it is sent in an encoding that it's better for the sending the information to the wire. So the decoded box content is equal to base 64 package, and this is base 64. I think it's called, yeah, 64 decode of the box content. So if we remember in the contract, we save the box content as the bytes version of the asset amount followed by the bytes version of the unitary price. So I think that's what we expect to see here from bytes. So this function takes a bytes array and decodes it to an integer, like a Python integer. So the decoded box content from 0 to 8, the 8th byte. Big endian for the ordering, and this should be equal to 3 units. Okay, let's do something similar for the price. The price starts at 8 and goes up to 16, and we expect the price to be 1 algo per unit of the asset, so that would be 1,000,000 micro algos. Okay, perfect. I think this is a good place to stop the recording, and then we will do the rest of the tests. So we took a look at how testing the deposit works, and yeah, we just checked that the result is what you expect to be. So the content of the box, which will be used going forward for handling sales, is correct, and it is what we expect. And I don't see any questions, so I think we're good to go with the next recording. Okay, so continuing on with the testing, I'm actually, like, since the test deposit is very, very similar to the test first deposit, I'm just going to copy this test. Oh, what happened? Just going to copy this test. And the only thing that we need to change is that this is a test deposit, and we're not calling the first deposit, we're calling the deposit method, which does not need an MBR pay because the box is already paid for. Oh, and yeah, the deposit doesn't change. The price of the sale, and yeah. Oh, but it changes the deposited amount. And let's deposit just 1,000 into the contract. So the price shouldn't change. Okay. Now this should run, right? Okay, perfect. Oh, so I now remember that we don't actually need the extra fee. So let me get rid of that. So what should we test now? We have an allow asset, we have tested that. First deposit, set price. Okay, now I think it's a good time to set the price, and what we'll do is similar to what we did for deposit, but the only thing that will change is not the deposited amount, but rather the price for the sale. So yeah, let's write that test. It's an Algorand client. I'm just putting some code there just because I want to link to the code. Yeah. We're still writing this. So, well, what I actually want to do is set different prices for each asset, right? So what I'm going to do is I'm going to create an array that not only contains the asset, but it contains a tuple of an asset and price. So let's sell the first for 3.2 algos each unit, and a second for 5.7. Now the box key is the same formula as before. The result is set price for the asset nonce is 0 because they are orders for different assets. And the unitary price, oh, I see. We should decompose the tuple into an asset and a unitary price. Okay. And we also need to include the box of the transaction. Like usual, let's confirm that the transaction have executed successfully. And now I think we still want to read the box content, but we're only interested in the, yeah, we don't care about the deposited amount. We want to check that this is equal to the unitary price. So yeah, we're still decoding the box, the content of the box, and we're reading starting from the 8 byte, and the result should be same as the unitary price. Okay, perfect. So, well, we have 2 tests ahead of us, and then we can consider this testing done. So test by, oh, well, actually, we copy this bit of the testing because it's always the same. Or only this time we have the buyer and the creator. We need the creator because we need someone to send the assets to, and the buyer, we're going to see how we're sending the method call as a buyer and not as the creator. Okay, so same prelude. We need the asset. Oh, we need the box key. Hold on. Oh, I forgot about for loop. We need an asset in test asset. Ah, hold on. I had the name slightly differently in my script than I do now. Okay. So for each asset, we're going to try and buy the content of the sale. So the result is equal to digital marketplace buy method. The owner, in this case, is the owner of the sale. This is the creator address. The asset is the asset. Nonce is equal to 0. What are we missing? Draw by, so the owner, asset, and nonce, these are the information used to identify the box, and then the buy pay and the quantity. Perfect. So I think that we want to buy, what do I have in my example? Oh, we want to buy like a kind of a strange quantity, just because we want to be able to test strange numbers, and usually when numbers are too simple, perhaps you're not testing everything, or like you may be missing some weird corner case. So let's figure out, oh yeah, this is the buy pay. So this is the transaction that is going to, so let's figure out, oh yeah, this is the buy pay. So this is the transaction that is going to pay for the asset. Transaction with signer, and so the signer will be the owner, buyer, signer. Now, the funds, again, do not go through the contract, they go directly to the creator. The amount, we have to figure that out because like we used different prices, but the quantity stays the same. So we should need to figure out how much to pay for that, but let's put a pin on that. And let's add an extra fee because we have an inner transaction. We have the asset transfer for the buy. Okay, the quantity. So, okay, so this is the price for both assets. And let's do something similar to what we did before. Let's wrap this in a new thing, and this will be the amount to pay. So this is the price, and we're buying this quantity. So I think we can run some calculation. So we have 2,123 as a quantity times price. Okay, so this is using my calculator. This is this number right here. Okay, so we will need to correct this number exactly by the amount of decimal digits in the asset, because this number is now too big, because this would be so leave 6 numbers, so this will be 6,000 algos, and we'd expect to pay well, we would expect to pay. So let's figure out. Oh yeah, this is the buy pay. So this is the transaction that is going to pay for the asset. Transaction with signer, and so the signer will be the owner. Buyer, signer. So using my calculator, correct. Say times 2.123 ASA. Well, we would expect to pay 3.2 times 2.123. This is what we would expect to pay. Around 6 algos. So what do we know about this asset? Well, we know that it has 3 decimal digits, right? We have created them at this point. Yeah, they have both 3 decimals. So that means that we need to divide this number by 10 to the 3 by 1,000. Okay, so this is the first price. I'm not going to redo the whole calculation from scratch, but it's essentially this number. A bit more than 2 units times, yeah, 5 algos each, 5 algos.7, that comes around to 12 algos total. So yeah, that's what we're sending the creator. And the test here is that this transaction should should execute successfully. And also we want to read the the holding of the asset in the buyer, and we want to read that this transfer of this quantity actually happened successfully. So that's with algo account asset info. This time is the buyer account, buyer address, and for that asset. And we want to read asset holding and amount. This should be equal to 2 units and 123. All right. Oh, we didn't even add the box. Oh, so this is why linting is very important. Amount to pay. This has to go into the amount. Perfect. And we have to add the box. And we also have to tell the client, the digital marketplace client, so the app client, to not send the transaction from the creator, because currently this client is associated with the creator. We did that here. Yeah, we set the creator as the default client that sends transaction, as the default address that sends transaction from that client. So transaction parameters, sender is the buyer, and the signer is the buyer signer. And boxes, of course, 0 and box key. Okay. Perfect. Let's test. Perfect. Okay. So yeah, this is telling us that the buyer, once he executed the buy method, we observed his account, or in general their account, to go up to the quantity that we bought from the contract. We have one last test, which is testing the withdrawal of the contract, really important feature. Creator. Now we have the same setup as before. Need the box key always. And we need something to compare, like the balance of the assets. Hold on just a second, I have to pause. Okay, I'm back. I'm sorry, I had to sneeze. I don't remember what I was saying, but oh yeah, right. So we want to compare it. We want to compare the before and after calling this contract, right? Because in the withdraw method, we're going to get back. Hold on. Oh yeah, okay, perfect. Yeah. we want to make sure that we both get back this for sale box MBR as well as any unsold items. So I'm going to call the before call mount Algorand client algorithm and the account info for the creator address. And this is, I'm just interested in the amount. So how many algos are in the account before the call. Then result is a withdraw. Asset is the asset. Nonce is 0. And we will need some extra fees, right? But we're not using the Algorand client to create this transaction. We're using the digital marketplace client. So don't worry, I'm going to show you another method in a second. But we also need to include the box at the very least. Boxes. Box key. Perfect. Okay, so how can you, increase the fees for a call created with the digital marketplace client? Well, the transaction parameters accept an SP, a suggested params object, which I'm going to set to nothing for the moment. But this suggested params is what we were talking about at the start of this session. And it's just an object that helps you create transactions. One of the things that it helps you set is the fees associated. And like in theory, like if you do an algorithm client, I'll go the suggested params. Now, by asking a node what parameters they are suggesting for your transaction, the node should be able to tell you, and I mean, the node will tell you if there is congestion in the network that you need to increase the fees and by how much you need to increase them, and like what's the latest block, what should be the validity of that transaction. So let's create an object like that. And then we need to modify it because we need to set the flat fee to true. And we need to set the fee to cover for 2 extra transaction. So 1 plus 2 extra is 3. And anywhere else that we have used extra fees, that's just the fees on top of the base fees. Because the Algorand client will like silently do everything for you, but you need to tell it if you need to include something extra. So yeah, this should be SP. And the only thing that we're missing is checking the after call amount. Yeah, let's copy that. And this is the after call amount. Now, the difference between these two should be equal to what we expect to get back as a box MBR minus the fees that we paid. And we also expect, like, let me copy this bit right here. We expect the creator holdings to be, well, let's do the math. So we started with 10 because we created them, and then we sold this amount, right? So again, going for my calculator, we had 10 minus 2 units and 123. We should have 7 units and 877. Let's test that hypothesis. Okay, great. So yeah, we can confirm. I think now the confidence in this contract has increased a little bit, and I think there are multiple things that you would like to check about this contract. For example, you would want to maybe vary the nonce too, same as we are doing for every other parameter. You would want to perhaps observe the behavior of the contract. For example, if you try to set the price to 0, which is something that we haven't, I don't think so. Yeah, this is something that we haven't checked for. So, in theory, you're allowed to give the asset for free, which is fine if that's what you want to do, but you probably want to have a test in your test suite that checks if you can set the price to 0, right? That would be interesting for you to, if that's what you don't want to happen in your digital marketplace, then you can create a test for that. So, there could be a number of parameters that could be varied. You could try assets with different decimals and see like how far this formula and how far the rounding will take you. And when it starts perhaps to break down, I don't think it should because we operated with safe numbers, but nevertheless, I think this is a good state, and it will be pretty hard to change this contract now and give it a new feature and break down what you already have because you have tests covering for you. So yeah, I think this can conclude testing of the contract. Camilo, I think the stage is yours. Joe. What's up?
Awesome. So thanks, Giorgio, for this incredible session 2. As we discussed at the beginning, testing is a very important practice. And today we learn how to start doing in our new contract. And Algodebs, how do you find today's session? I learned a lot, and this is a very important session because each of the tests will help us to understand key features of and concept of Algorand that later we can use for our own projects. But still, maybe Joe and Giorgio, I have one question. What recommendation do you give us for creating good tests for our contracts? What we need to consider when we are trying to create this testing?
Okay, there you go. Can you hear me now?
Yeah.
Okay, perfect. Yeah, so in general, following along to kind of what we've been doing here, which is you have your methods, there's a way you expect them to work, and you want to that they work as you expect them to. And that's very important. And that's generally the easier part of testing, right? Is just making sure good inputs results in good outputs. The other level of testing that you also want to do a little bit that you can expand much more on this contract specifically. And if you're finished the intermediate bootcamp and you still want to more, this might be a good thing to do, is to start giving your contract some bad inputs and basically trying to break it. So not just testing to make sure it works as you expect, but making sure that other people can't break it. And this, as Josh in the chat says, right, making sure you touch all your code paths and making sure that you really test all the different possibilities for how someone might interact with your contract, even if they're doing it incorrectly. And making sure, and like again, like Josh says, making sure that everything fails gracefully and fails like you would expect it to is a critical part of testing before you go to production.
100%, and that is something that you will learn when you try to create your own smart contract. In that way, you can identify how it will be work, and you can create your own test. Dimitros asks, do the devs use these tests as a template or just rewrite every time from scratch?
Yeah, that's a great question. So generally, because every contract can be so different, it's hard to come up with a generic template that can be used for everything. But that's kind of where allocate utils comes in, and it provides helper functions for like getting the dispenser account and funding accounts for things that you often find yourself doing. Generally, in production, what typically ends up happening is you find things that you end up doing over and over again across both your tests and your front end and your back end, and you can write helper utilities within the context of that contract. So if you as a developer, you find yourself working on marketplace contracts a lot, then you'll probably have your own template for the contracts that you work on. But it can be a little bit difficult to provide a comprehensive template that's like generic enough for all the different things that you can do in a contract. But if you find yourself, keep doing something and you want it to be a feature in AlgoKit, you can make an issue on the AlgoKit repo or let us know in Discord. We're always looking for ways to improve that. And the best way to do that is by getting developer feedback. So definitely let us know if there are improvements that you think could be made as well.
Awesome. I don't think we have more questions. Oh, yeah. Maybe, Georgia, you want to say something?
Only if we don't have more questions, which doesn't seem like we do at the moment. No, I would just like to second what Joe has said, and you should definitely try and give illegal inputs to your contract and make sure that they fail gracefully. So, for example, for this contract, you could try and modify someone else's box and see how that goes. You could try and call deposit method before calling first deposit. And these are all things that you can try to do and break your contract, because as developers, we often get into some kind of blind spot where we assume that the inputs are going to be good for the contract, when in reality there are a lot of actors out there which will try to take advantage of vulnerabilities in your contract. And in this regard, I would like to point out that maybe when writing a smart contract, it's one of those cases where the lines of the actual software are much less than the lines of the actual tests. So your smart contracts tend to not be that long, but the tests do. So write any test that you feel like it's important. And also AlgoKit, one of the things that it provides you with is an utility called TL audit. And when you build your contract, that produces an artifact in your project folder, and it creates TL files. And you can run this utility on those TL files, and it will do kind of a low-level check of your contract and make sure that it doesn't have known vulnerabilities or like known easy to avoid mistakes. So that's what I recommend doing.
Thanks, Giorgio. I don't think we have more questions. I don't know, Joe, if you want to mention something else before we end today's session.
And no, I think we've covered a lot of good questions here.
Awesome. So thanks everyone for joining us today, and looking forward to seeing you in tomorrow's session. If you have any question, feel free to join to the Discord, ask the question over there, and help us to answer questions, because sometimes we don't have enough bandwidth to answer the full detailed question. But thank you so much, and see you tomorrow.